Continuing on with the polymorphism challenge solution from the last video, I'm showing you the challenge slide from that last video again. In that video, we built the car and the gas-powered car classes. I overrode the start engine and run engine methods on gas-powered car, but I didn't override the drive method. Let's override that method and also create the electric car and hybrid car classes. I'm working in the same project I created in that last video, polymorphism challenge. I'll start with creating the two other subclasses of car. Let's close the gas-powered car node because I want to copy this node, which really copies the whole class, and then paste that node below it. Highlight the duplicated class node and then select, edit, find, and replace. Control R on Windows is the shortcut for this replace feature. While everything is highlighted, I'll change all references of gas-powered car to electric car in the highlighted code, then hit the Replace All button. And that replaces all the references to gas-powered car with electric car for the copied class. Let's make a couple of changes to the electric car class. I'll change the average kilometres per litre to average kilometres per charge. I can highlight that field, select Refactor, then rename, and change litre to charge. And select to change the parameter name as well there. And I'll go through the same process for cylinders. Highlight it, refactor, rename, then change it to battery size. And again, I'll check the option to change the parameter name in the constructor. Finally, I want to change the way the start engine and run engine methods work. I'll call these BEV for short, which stands for battery electric vehicle. I'll output a message for our BEV start engine method, and then change the output for the run engine method. And let's repeat that process once again, but for the hybrid car. First, I'll close the electric car node and paste the gas-powered car again. And highlighting that last pasted gas-powered class, which should still be a closed node. And I'll use the replace functionality to change gas-powered car to hybrid car, and select the Replace All button. Okay, there's my third subclass. The fields are the same for a hybrid car as a gas-powered car, which actually is what I want, but I also need an electric vehicle battery size, so let's add that. It will be an int called battery size. I'll also add it to the constructor code. I'll do this manually and just include it as a parameter to the constructor first. Int battery size. This .battery size equals battery size. And now let's change the overridden methods for the hybrid car. First, I'll edit the start engine method, and for a hybrid, I need to fire up cylinders and switch the battery power on. I'll output a message for our hybrid start engines method confirming the cylinders, and one for the battery as well. And next, I'll edit the run engine method. I'll output a message that looks the same as the one I used for a gas-powered car. You might want to write more code here with something about the battery as well as adding appropriate fields to this class for that. To keep this simple, I'll just have it run like a gas car for now, and just print the hybrid keyword. Now I want to go back to the main method and create some of these instances. First, I'll create an instance of an electric car, and I'll make it a 2022 Tesla Model 3, and say that it can go 568 kilometers on a battery that has a size of 75 kilowatt hours. Car Tesla equals new electric car 2022 red Tesla Model 3, 568 and then 75 is the last argument. And I'll pass Tesla to the run race method. And if I run this code, that's the output for these statements, which shows that the methods I overrode for the electric car were successfully executed. This means the behaviour for the electric car, the battery electric vehicle BEV, is different than the gas-powered car or a generic car. That's what I wanted, so that's good. Lastly, let's test out the hybrid car. I'll set up a Ferrari SF90 which has 8 cylinders and only an 8 kilowatt hours battery. Car Ferrari hybrid equals new hybrid car with the following 4 arguments: 2022, black Ferrari SF90 Stradale. 16 for average kilometres per litre, 8 cylinders, and 8 for battery. And I'll invoke the run race method, passing the Ferrari hybrid object, and I'll run this. You can see that the last car is a hybrid car, There are 2 steps to starting up, 8 cylinders are fired up, and the 8 kilowatt battery is switched on. And that was the challenge. In this example, we created a polymorphic method on the main class. This method only knew about the car class and not about any of its subclasses. And it could be executed for many different types, as I showed. Now, maybe you went the extra mile and created a factory object like I showed you in a previous video, which made the code in the main method much cleaner. That would have been another good approach here. I hope you were able to implement something similar that used the car class as the declared compile time type. This demonstrated that at runtime, it executed different behavior on different objects, all of which could be called a car in a way. And hopefully you were able to code that, and maybe you had a little fun with it and customized the behavior for each car type in some way. Okay, that's the polymorphism challenge, and that's actually the end of the object-oriented programming sections, other than one last challenge that I will talk about shortly. I've covered many object-oriented features of Java in these sections, including inheritance, encapsulation, polymorphism, and composition. In the next video, I'm going to give you a bigger challenge than usual to go over all the object-oriented features I've discussed and put them all into practice in one application. Let's move on, and I'll see you in that next video.